Day 3, using graphs and tables to solve linear systems. Our objective today, we will be able to solve systems of equations using the three methods: graphing, substitution, and elimination. We will also classify these systems of equations using slope and y-intercepts. A system of equations is a set of two or more equations. A linear system contains only linear equations. A line is an infinite set of points that are solutions to an equation. To solve a system of equations by graphing, we're going to graph both of the equations on the same coordinate plane. We're going to find the point of intersection, and then we're going to state that point as an xy ordered pair where both equations intersect is our solution. So example 1 says, use a graph to solve the system, then check your answers. So when we graph a line, we want to use y equals mx plus b. Remember that m is your slope and b is your y-intercept. So looking at this first example, remember where there is no number in front of a variable, you have an invisible 1, and every whole number is over a 1. Our 4 represents our y-intercept, so we can plot our y-intercept at 4. Our slope is negative 1 over 1, so we're going to go down 1, always run to the right. Continue down 1, right 1, down 1, right 1, then you can go the other direction. And you just graphed our first line. To graph our second line, we want to start with our y-intercept, which is negative 2. So we put a point on our y at negative 2. Our slope is 1 over 2, so this time it's positive 1, so we're rising 1, running 2 to the right. After you run to the right, you can put your points on your graph to the left. We just graphed our second line, so we need to find the point of intersection. So we can tell that these two lines intersect right here, and that is the ordered pair 4, because you always state your x value first, 0. So the solution to our system, where these two lines intersect, is 4, 0. When we're talking about systems of linear equations, we have 3 different types of systems. The first type of line that we want to talk about is two lines that intersect. And when we draw a picture of two intersecting lines, it looks a lot like what we just had in the previous example 1. Two lines that are intersecting at a given point. When we talk about the slopes and the y-intercepts of intersecting lines, our slopes are not equal, and our y-intercepts could also be unequal. We name this system by saying it's consistent and independent, and it has one solution, which is always that xy ordered pair where they intersect. The second type of line that we can talk about is parallel lines. Our picture, you can see the two lines are next to one another and they will never cross or intersect. They have the same slopes always, but different y-intercepts. We name this system by saying it's consistent and independent, and it will have 0 solutions because it will never cross. The last type of lines we talk about are coinciding, and that is when we have two lines that are on top of one another. So we draw the picture like so. The slope and the y-intercept, we say they have the same slope and the same y-intercept because they are the same line. And we say, to name that system, we say it's consistent and dependent, and it has infinite number of solutions because any point on the line would be the same for both lines. Example number 2 says, without graphing, classify each system and determine the number of solutions. So when we look at example A, oftentimes the easiest thing to look at is the slope and the y-intercept, which we saw in the table on the previous slide. So we can quickly solve both of these equations for y. We use the inverse of positive 2x, so we would get y is equal to negative 2x plus 3. In order to get y by itself in our bottom equation, we could subtract our 9. Then we would divide by a negative 3. Remember, if you divide one thing, you have to divide everything on that side. So we can see that we have negative 2x plus 3 equals y. So we notice now that the type of system is a consistent dependent system which means that we are going to have infinitely many solutions because the lines are the exact same thing. Looking at example B, in order to get y by itself, the inverse of a positive 4x is negative 4x. Divide by our 2, so we get y is equal to negative 2x plus 3/2. And when we look at the bottom one, the inverse of positive 2 is minus 2. So looking at our slopes and our y-intercepts, we can tell that they are both different. So we have a consistent and independent system, which means they will intersect in one place and have one solution. Example 3, we are going to use substitution to solve the following systems. The method of substitution is when you get one of the variables by itself and you substitute it into the other equation so that you are left with an equation that only contains one variable. You then solve for the second variable, substitute it back in to get your answer. So example A, y is already set equal or by itself to x plus 2. So we are going to take what y equals and substitute that into our bottom equation. So we will have x plus 2 equals 8. We then are going to combine our like terms to get 2x plus 2 equals 8. Solve for x using your inverse operations. So you get 2x equals 6. Inverse of multiplication is division. X equals 3. However, that's only half of our solution. So we need to plug that back in to one of the original equations and solve for y. So y equals 3 plus 2, y equals 5. The ordered pair where these two lines are going to intersect, or the solution to the system, is 3, 5. On example B, we need to get y by itself, and the first equation is the easiest. The inverse of positive 3x is minus 3x. So we get y is equal to 1 minus 3x. We then can take what y equals and plug that into our bottom equation. Don't forget to use parentheses when you have a coefficient. So 2 times 1 minus 3x plus 6x equals negative 18. 2 minus 6x plus 6x equals negative 18. Combine your like terms. Negative 6x plus 6x is 0. 2 does not equal negative 18, which gives us a false statement and tells us that there is no solution. The next method to solve systems of equations is elimination. The first step for elimination is you need to get one letter to cancel out. You're going to add or subtract the equations together, and then solve for one of the variables, plug that variable back in. So looking at example 4a, I noticed that if I add my two equations together, my y's will already eliminate one another. So I don't need to multiply either equation by anything. I can just add them up. 2x plus 4x is 6x. 3y minus 3y is gone, is equal to 30 plus negative 4 is 30. The inverse of multiplication is division, and I get x is equal to 5. I then have to plug that 5 back into one of my original equations to solve for y. So 2 times 5 plus 3y equals 34. 2 times 5 is 10. The inverse of positive 10 is minus 10. So 3y equals 24. Inverse of multiplication is division. Y is equal to 8. So the ordered pair of where these two lines would intersect is 5, 8. Looking at example B, when I look at my x's and my y's, neither one of them cancel out, but I can tell looking at my x's, if I multiply this whole bottom equation by negative 2, I would create x's that are inverse from each other. I then cross out the equation that I multiplied and I add my two equations together. 2x plus negative 2x, my x's eliminated each other, which is what we wanted. 4y plus negative 4y also eliminated each other, and negative 10 plus 10 gives us 0 as well. 0 does equal 0, so it's a true statement, which means we have infinitely many solutions. So remember, when you are using the elimination method, you can choose any number to multiply either of the equations by. You just want to make sure that when you add the two equations together that they will eliminate each other. Example 5 says 3 large popcorns and 2 small drinks cost $21 at the cinema. 2 large popcorns and 4 small drinks cost $22. How much is a large popcorn and how much is a small drink? We just need to set up the system and not solve it. So the first thing we need to do is we need to know what we're talking about. We're talking about popcorn and we're talking about small drinks. We need to define our variables, so I'm going to let P represent popcorn and D represent drinks. I then know that 3 large popcorn, the word and means plus, 2 small drinks, the word cost refers to an equal sign, $21. So 3 popcorns plus 2 small drinks equals $21. In our second sentence, it says 2 large popcorns, 2P, plus 4 small drinks, 4D, equals $22. So we just set up a system, and the best method to solve this system would be elimination, because looking at these two equations, there is nothing that we can substitute directly into the other. You now can complete your homework.